We all have them, moments that cling to our minds for years, a sudden fright that won't let go, the smell of a kitchen that pulls you back to childhood, a single sentence that replays and changes you. Why do some memories fade while others remain sharp, even decades later? Today we'll unpack the neuroscience, psychology, and everyday mechanics behind unforgettable memories. And we'll finish with practical steps you can use to make important memories stick or to weaken memories you'd rather forget. First, let's define what memory really means. Memory is not one thing. It's a set of processes: encoding, consolidation, storage, and retrieval. Encoding is what happens when an experience is converted into a brain signal. Consolidation is the process that stabilizes that signal into a longer-term trace, and retrieval is the act of pulling it back into mind. At each stage, there are factors that make a memory more or less likely to endure. Emotion is the single most powerful enhancer of memory. When an event triggers strong emotion, fear, joy, shame, the brain floods the body with stress hormones like adrenaline and cortisol. These hormones activate the amygdala, a small almond-shaped structure deep in the temporal lobe, and the amygdala in turn modulates memory systems across the brain. The amygdala helps tag the experience as important and boosts consolidation in the hippocampus and related cortical areas. That's why vivid emotional events, accidents, births, intense arguments, tend to become flashbulb memories. People remember them with striking clarity. But note, vivid does not always mean accurate. The emotional tag boosts retention of the gist and of central details, while peripheral details may still be distorted. The hippocampus is the next key player. It's essential for forming new episodic memories, the who/what/where/when episodes of our lives. The hippocampus binds elements of an event, faces, places, sequences, into a coherent memory. Over time, many hippocampal-dependent memories are gradually transferred to distributed networks in the cortex, a process neuroscientists call systems consolidation. That transfer takes time and is often sleep-dependent. Sleep, especially slow-wave sleep, boosts consolidation by replaying neuronal patterns that represent the original experience. So a night of good sleep after learning makes a strong memory more likely. Pulling an all-nighter often undermines retention. Distinctiveness matters. The brain is a pattern detector. It pays attention to items that stand out from the background noise. A single unusual detail, a novel sensory cue, or a dramatic context marks the memory as important. That's why an otherwise ordinary day becomes unforgettable if something unexpected happens. Distinctiveness also explains why repeated boring information is harder to recall. It blends into the background. Rehearsal and retrieval practice are practical multipliers. Every time you retrieve a memory, you don't just access it. You also update and reconsolidate it. Frequent spaced retrieval strengthens the neural pathways and makes recall easier in the future. That's why students who test themselves repeatedly over weeks remember better than those who cram. This retrieval-based strengthening is practical. Test yourself, explain the event to someone, or write it down to make a memory stick. There is an important twist: reconsolidation. When a memory is retrieved, it becomes labile again, temporarily modifiable, before it restabilizes. That's why new information or a new emotional context presented after retrieval can change the memory. Reconsolidation is now a major area of research and underlies therapeutic approaches for trauma. Carefully timed interventions during retrieval can alter the emotional charge of traumatic memories. Stress and arousal shape memory in complex, sometimes opposing ways. Moderate arousal enhances encoding and consolidation, but extreme stress can impair hippocampal function and fragment memories. That's why victims of severe trauma sometimes report gaps or fragmented recall. The brain's systems are overwhelmed. Similarly, substances like alcohol at encoding impair consolidation and lead to weaker memories. The biochemical basis of long-term memory includes mechanisms like long-term potentiation, LTP, a persistent strengthening of synapses following repeated activation. LTP and related molecular cascades, new protein synthesis, gene expression changes, transform short-term synaptic changes into enduring structural changes. That's the cellular foundation for why repeated and spaced practice, over days and weeks, builds durable memories. Context and cues greatly affect retrieval. Memories are often tied to the context in which they formed: the physical place, the smells, the sounds. Retrieval cues that match encoding context dramatically improve recall. That's why returning to a childhood room or smelling a familiar perfume can vividly restore a memory. Conversely, when context is lost, recall becomes harder. Social and narrative factors matter too. Memory is not only a biological trace, it's a story we tell. Recounting an event shapes it. Each retelling can strengthen the parts we emphasize and fade others. Culture, language, and social reinforcement decide which memories are rehearsed and which are ignored. This is why families, institutions, and nations maintain collective memories through ritual, storytelling, and monuments. So, what makes a memory truly unforgettable? It's rarely one single thing, but a powerful cocktail of key ingredients. First, strong emotion. Intense feelings release hormones like adrenaline that act like a highlighter for your brain, signaling to the amygdala that this is important, save this. Second is distinctiveness. An event that breaks your routine stands out against the mundane, making it easier to recall. Third, repeated retrieval. Every time you recount a story, you strengthen its neural pathway, carving it deeper. Finally, there's sleep-dependent consolidation, where your brain replays and transfers important memories to long-term storage while you rest. When these factors converge, you get phenomena like flashbulb memories. Think about where you were when you heard about a major public event. The memory feels exceptionally vivid, like a photograph. However, research reveals a paradox. While our confidence in these memories remains high, the details are surprisingly prone to error. We might misremember who told us the news or what we were doing, often because we unconsciously incorporate post-event information from news reports or conversations, subtly rewriting the original memory trace. This malleability is critically important in the legal system with eyewitness memory. The intense stress of witnessing a crime can impair memory for details, sometimes causing a weapon focus that prevents encoding of a perpetrator's face. Post-event information, like leading questions, can further distort recollection, creating confident but inaccurate testimony. This is why the justice system now emphasizes careful interview techniques that avoid suggestion and stresses the need for corroborating physical evidence, acknowledging that even the most certain memory can be flawed. There's also the problem of painful memories that persist too well. PTSD is in many ways the pathologically persistent memory. Therapeutic approaches exploit reconsolidation and controlled exposure to weaken the emotional charge. Techniques like prolonged exposure or certain reconsolidation blocking pharmacologic adjuncts aim to reduce the intensity of traumatic memories while preserving factual knowledge. So, how can we leverage the science of memory? Let's explore evidence-based strategies for making memories last. First, prioritize good sleep after learning. During deep sleep, your brain replays events, strengthening neural connections and transferring memories from the temporary hippocampus to the long-term neocortex. This consolidation process is essential for making memories stick. Next, embrace spaced retrieval. Instead of cramming, which leads to fragile recall, space out your review sessions. Testing yourself after a day, then a few days, then a week, signals to your brain that this information is important and worth holding on to. Make memories distinctive. Our brains better remember things that stand out. Link new information to vivid mental images or strong sensory details. Techniques like the memory palace leverage our powerful spatial memory. Actively elaborate on the material. One of the best ways is to explain it to someone else in simple terms, which forces you to truly understand it. Also, connect new facts to what you already know, weaving a richer network of knowledge. Finally, reduce distractions during encoding. Your attention is a finite resource. When you multitask, you create a weaker, fragmented memory trace. Give the moment your full focus to build a strong foundation for a lasting memory. So how can we weaken the grip of a painful memory? It's crucial to approach this carefully, ideally with a therapist's guidance. The key lies in a process called memory reconsolidation. When we recall a memory, it becomes temporarily unstable before it's stored again. This brief window is our opportunity. Therapies leverage this by having you retrieve the memory in a controlled, safe environment. This isn't about reliving trauma, but recalling it just enough to open that window. Techniques like mindfulness help you observe the memory's feelings without being overwhelmed, detaching the emotional sting from the event. Cognitive reappraisal goes a step further, helping you actively reframe the story, perhaps focusing on your strength in surviving the event. In some clinical settings, this is paired with pharmacological agents like beta blockers, which dampen the body's stress response during recall, helping to sever the link between the memory and its intense emotional charge. So what does this science mean for how we live? First, recognizing that memory is a reconstructive process, not a perfect recording, should make us cautious about our own recollections. Our memories are subtly rewritten by our current beliefs and emotions. This understanding also encourages generosity when others' memories differ from our own. It's often not dishonesty, but two minds with different reconstructions of an event. More importantly, this knowledge empowers us. We have practical control. By prioritizing sleep, we consolidate information. By focusing our attention, we encode new information strongly. By managing our emotions and using rehearsal, we can consciously choose which memories to strengthen. Ultimately, we are not passive observers of our past. We are active gardeners of our minds, with the power to cultivate the memories that serve us and gently prune those that cause us harm. If you enjoyed this exploration of memory, the molecules, the minds, and the methods, subscribe for more episodes that combine neuroscience with practical life skills. Thanks for watching.